All right, so this second part of the video, or second video, is going to be some word problems and then some other types of problems that we're going to look at in our Savas homework. So this one says, find the zeros of a quadratic function. A multi-level driving range has 3 levels. Marco hits the golf ball from the second level, which is 32 feet high. Notice how high it is also the y-intercept where it starts. The height of the ball, x seconds after Marco hits it, is modeled by the function h of x equals negative 16x squared plus 16x plus 32. When does the ball hit the ground? So we are trying to find when this ball gets back to the ground, which would be a height of 0. Okay, so we're trying to find the zeros. So I'm going to do this 2 ways. I'm going to show you how to factor it, first of all. Negative 16x squared plus 16x plus 32. I want to know when that hits the ground, which would be at height 0. So it's equal to 0. So I'm going to use my factoring skills. I'm going to factor out a negative 16. That's going to leave me with an x squared plus x plus 2. Now all I'm looking for is 2 numbers that multiply to 2 and add to, what did I do? I didn't change signs. Sorry. Whoops. This should be when I factor out a negative 16, this becomes a minus and this becomes a minus. So I've got the negative 16 there. I've got the x minus 2 and the x plus 1, right? 2 numbers that multiply to negative 2 and add the negative 1. So setting these each equal to 0 and solving it. Plus 2, x equals 2, negative 1, x equals negative 1. Now, again, this right here, where we're talking about x is seconds after Marco hits the ball. There's no possible way for it to be negative 1 seconds. So my answer is 2. After 2 seconds, that ball is going to land and hit the ground. Okay, so that's one way to do this. Notice how I ignored that negative 16 outside there. The only time I include this and set it equal to 0 as if it were to have an x. If it's just a number, I leave it alone. It has no effect on the zeros. So if I were to look at this problem on, let's see here. If I were to look at this problem on Desmos, okay, and I put in negative 16, I know it's whatever. If it said t squared or x squared, it doesn't matter. You can use either one. Plus 16x, then it was plus 32. Plus 32. Okay, notice where it crosses the x-axis. Look, the graph shows me. Know that x-intercepts are where the graph crosses the x-axis, and you don't have to factor it. You can literally just type it in there. So let's take a look at the next example. I'm not even going to factor this one. I'm just going to type it in. Negative 16x squared says, how long will it take the ball to reach the ground? Boom. So we're talking about a ball that's being thrown. We want to know how long it takes to hit the ground. So that's when it would equal 0. How long will it take to reach the ball? We're just going to enter this into Desmos. Okay, negative 16x squared. Negative 16x squared plus 32 plus 128. Negative 16x squared plus, what was it, 32x. That was a plus 128. And of course, it can't be negative. Okay, we're at the top of the building, and it takes 4 seconds. So the answer to that is just 4 seconds. Plug it into Desmos and go from there. Okay. Couple of examples in the homework kind of deal with this. And it says factored form of a quadratic function can be written as factored form. Okay. So P and Q are the zeros of the function. The x-intercepts of the graph correspond to the zeros of the function. 2 zeros denote 3 intervals of x values. So what we're looking at here is you could have a problem, first of all, that looks like this. Y is greater than or equal to x squared plus 5x plus 4. Okay, and to do this problem, we would say y is greater than or equal to x plus 4, x plus 1. And then what would the zeros be? The zeros would be negative 4 and negative 1. So on a number line, here are the 3 intervals. Okay, all the numbers here, which are x is less than or equal to 4, all the intervals here that are between negative 4 and negative 1, and then x is greater than or equal to 1. So when you have these and you plug this into Desmos, if I were to plug in y is greater than or equal to, I'm looking for the values where this is true. Okay, greater than or equal to. So if I went to Desmos and I plugged in y is greater than or equal to, where Where's greater than or equal to? Get that out of here. Gonna move this. There we go. Y is greater than or equal to, and what did I say? X squared plus 5x plus 4. Notice the intervals where it is shaded. So this would be everything between 4 and -1 because that is where it is shaded. Okay, so we would say everything between -4 and 1 is my solutions. This is not shaded outside of here. Okay, so I think there's a couple problems that look like that. Just graph it and find the interval where it is true. It's between -4 and 1. Look, if I switch this to a less than symbol, it's everything on the outside. So it'd be from negative infinity to -4, and then from -1 to positive infinity. So that's the inequalities that we have there. And then the last thing, we did these problems, we're going to use linear regression. It says write a parabola, an equation of a parabola with x-intercepts at -2, 0, -1, 0, and passes through the point -3, 20. We're going to plug this into Desmos, okay? -2, -1. So how do I plug that into Desmos? I go to a blank table. I'm going to enter those values into the table. So I'm going to go and enter in a what? -2, 0, -1, 0, -2, 0, a -1, 0. I think it was -320. Okay, it doesn't matter the order that you put them in. So -3, +20, -3, +20. And I'm going to put down here my little y1, the little tilde, ax1 squared plus bx1 plus c. And here is my parabola. A is 10, B is 30, C is 20. So I would say 10x squared plus 30x plus 20. That has those parameters right there. Okay. There's a couple problems like that on the homework. So sorry I'm not here today. Hopefully this kind of helped you out. You guys should be able to do that using a linear regression. Again, if you need that formula, it's this right here, y1 little tilde ax1 squared plus bx1 plus c. All right, guys, have a great day.